Hey, welcome back to Mr. P Helps with Algebra 2. This is Unit 2, Topic 2, SLT number 18, as we talk about remainder theorem and factor theorem. So we're dividing polynomials now. Starting off with a pretty quick warm-up with just dividing long division with regular numbers. 5 doesn't go into 4, but 5 does go into 43. It goes in 8 times. 8 times 5 is 40. So that remainder is 3, and bring down your 5. 5 goes into 35 exactly 7 times. So is factor a 5 of 534? So the answer is yes, because it did go in evenly, because 5 goes into 35 exactly 7 times, leaving you with no remainder in this case. 9 goes into 12 once. Subtract, you're left with 3 left over. Bring down the next 3. 9 goes into 33. What is that? 8, no, sorry. 3 would be 27, 4 would be 36. So 3 times that would be 27. Subtract, you're left with 6 left over. And 9 does go into 64. 9 times 7 would be 63. And subtracting, you're left with 1 left over. So is 9 a factor? So that would be no, because you had a remainder of 1. Because 9 times 7 is 63, subtract, and you have a remainder of 1. So what is a factor? A factor means that it goes in evenly. Write the complete factorization of 30. So 30 can be 15 times 2. I'm doing a factor tree. This is a prime factor. And this is 5 times 3, that's a prime factor, and so is that. So this is 5 times 3 times 2. That's the prime factorization. So these are all the factors that make up 30. 5 times 3 times 2. We're going to do the exact same thing, only with polynomials. We're going to write the complete factorization, which means all the factors down to their primary factor, which in this case would be all prime numbers. For a polynomial f of x and a number a. So basically what remainder theorem is if you get a remainder of 0, then it is a factor of that number. If it divides evenly, it is a factor. And if it has a remainder, then the remainder is the answer in that case. So whatever it ends up with. That is the idea of your remainder theorem. Whatever your answer is the answer. So I'm not going to do this question because that's really just long division. It's kind of the exact same as we had done before. If it goes in evenly, then it has no remainder. So I believe this one had no remainder, so therefore 27 is a factor. I could be wrong. Maybe it did have a remainder. If it did have a remainder, then therefore 27 is not a factor. That's the case. So when you're dividing polynomials, and this is more important, you look at the highest degree of what you're dividing by, and their dividend on the inside, so whatever it's the biggest degree right here. So you ask yourself, what would I have to multiply x by to make it x to the third? And that's x squared. This times this is this. And then I multiply this times this as well. So that makes negative 10x squared, and I subtract one at a time. That minus that is nothing. Negative 12 minus negative 10 is really negative 12 plus 10, which is negative 2x squared. Bring down my next term, just like you do in long division, and do it all again. What would I have to multiply x by to make it negative 2x squared? That would be negative 2x. Negative 2x times x is negative 2x squared. And negative 10 times negative 2x is positive 20x. Subtract these terms. Well, anything minus itself makes nothing. That was the whole point. 12 minus 20 is negative 8x. All right, last one. What would I have to multiply x by to make it negative 8x? And that would be negative 8. Oh, I forgot to bring down my 80. So x times negative 8 is negative 8x, and negative 10 times negative 8 is positive 80. Subtract. Anything minus itself is 0. Anything minus itself is also 0. So the remainder is 0, so therefore x minus 10 is a factor. It is a factor because there's no remainder. That's based upon remainder theorem. So in this case, the answer is x minus 10 times x squared minus 2x minus 8. And this times this equals this right here. Now, this is not completely factored, so this may or may not be able to be factored again, which is, I believe, what we're going to do in the next one. Oh, no, we just start off with a new question. Write the complete factorization, so I would then factor that leftover again. So in this case, I've already done quite a bit. So I've already done that whole So I've already done this whole thing divided by this, x minus 10. So I know x minus 10 is one of the factors, and I'm actually not going to solve this again. I'm going to then factor the x squared minus 2x minus 8. X squared minus 2x minus 8. So I'd already done this question. So now let's see. Is there any numbers that give me negative 8 as a factor but also add up to negative 2? And that would become x minus 4 and x plus 2. Negative 4 times negative 8. I'm sorry, negative 4 times 2 is negative 8, and negative 4 plus 2 is negative 2. So now we've got our complete factorization, which is this. This times this times this is this. That's your complete factorization. All right, so this time we're dividing by x minus 5. Is x minus 5 a factor of this? No, it's not. So f of x minus 5 is negative 35. So therefore, x minus 5, therefore 5, I should just write 5 in here, sorry, because that's the factor of 5. 5 is not a factor. It is not. So is it possible to write complete factorization? Well, no, it's not. At least not here. So x minus 5 was, maybe something else can go into it equally, but x minus 5 cannot. But you did get this. Okay, so this times this, but the remainder is negative 35, so no. Same thing here, but it looks like x plus 2 does go in equally, so negative 2, f of negative 2 is 0. So therefore, the complete factorization is x plus 2 times, now I need to factor this again, x squared minus 14x plus 40. I'm looking for two numbers that give me 40 when multiplied, but add up to negative 14. And that would be negative 10 and negative 4. So x minus 10 times x minus 4. Negative 10 times negative 4 is 40. Check. And negative 4 plus negative 10 is negative 14. Check. There's your complete factorization. And that's where I'm going to stop this video. Thanks again for watching, and look forward to more videos for more topics. Have a wonderful day.